the second part of our lesson, we're going to look at the cosine law. And so to introduce you to the cosine law again from grade 10, just a review, if you actually calculate this side length C with Pythagorean theorem, you'll see that the calculation is pretty routine. And so we're adding the 144 and the 25, and we're square rooting the 169 to get 13. Over here, we just asked the question, if this 90 degrees just closed in, what do you expect as an estimate for the length of C? If that 90 degrees actually just opened up from 90 to 110, what do you expect to be the estimate of C? And so we actually know that for the second one should be lower than 13. It might be like 12 point something. And the third one is higher than 13, and that's what we're expecting. Question is how much higher or lower? And that's actually seen in the cosine law. That's the 2ab cos C part. That's not the distance because we still have to square root. But that's the correction to Pythagorean theorem that the cosine law applies. And that's how the cosine law works. The cosine law works such that it's really like Pythagorean theorem, subtracting 2ab cos C. And the 2ab cos C is 2, and this can be proven. You can watch, like you can YouTube another video for proof of the cosine law. But 2 times A times B times the cosine of C, and we'll see how that works later. It's very close to Pythagorean theorem though. We calculate it very similar. We just subtract this amount off. Now in acute, it will always subtract off. In an obtuse angle, we have to find a way to make that C bigger. And so we'll see what happens in this lesson. Now don't let these formulas confuse you. It's just saying, the three of them just saying that you can do it with any side length. You just use the angle that's across from the side you're looking for. And so if you just want to look at one version of the formula, then you're just looking at like making sure that the angle that you put in is across from the side you're looking for, or the side that you call C is across from the angle that you're looking for. And then A and B can be any of the other two. And make sure we understand how this happens, and we'll see a calculation. So solving problems, and this isn't just the cosine law, so we're going to look at two forest fires 20.3 kilometers apart. The angle, you got like two towers, and they're making a triangle. And so I just read the question, make sure it's not talking about anything three-dimensional. It's really just looking at things on the ground because it doesn't say anything about angle of elevation, or so we assume that all of these measurements are just on the ground. And so we can say that two fire towers are 20.3 kilometers apart. We call them A and B. The angle at tower A is 45 degrees, so we're going to make an angle with the fire. The angle at tower B is 80 degrees, and so I know that that's not to scale, but which is actually I like better because I don't want to spend a whole bunch of time trying to draw it accurately. I'm just trying to get the information down. How far is the fire from each tower? So we're actually looking for this distance and this distance. So we actually have, this is a sneaky one, but we do have enough information for sine law. We need an angle and a side across from it for sine law, and we actually have this angle. And so if you think about it, the angle adds up to 180. It's got to be 55 degrees. So we can call this is our like ammunition for sine law, and then we can solve for these sides separately. So solve for side A first. A over sine 45 is 20.3 over sine 55. Cross multiply sine 45 times 20.3 and divide by sine 55. You can do that all at once. You get 17.52 kilometers. Same thing for side B. It's just using the 80. So it's almost the exact same calculation, and you get 24.41. And that's how far apart they are from each tower. So some 3D situations, this is kind of an interesting triangle that seems to come up a lot. And so this is a helicopter above a point, above some point on the ground, but the hikers are somewhere else. And so just some language here. With angle of depression is the angle that the helicopter looks down at. It looks straight across and then look down at 9 degrees. And so the helicopter is 200 meters from the bottom. And so the 3D comes in, so 142 is actually on the ground because it says it's on the ground. Sometimes it's up in the air from where the helicopter is looking down on the hikers. We'll see a question like that. But right now it's on the bottom. And so we're looking down at these two hikers from the helicopter. The angle of depression is 9 degrees is actually same if you think about like looking out and looking down. The Z pattern tells us that that's the same. Just watch my cursor here. Looking out straight out, just parallel to A, but like straight out into the air, and then looking down, that would be a 9-degree angle. So the 9-degree angle just from the Z pattern is actually also the same as the angle of elevation. Same with the 13 degrees. So those angles we actually know, and we're looking for the distance between the hikers. So we have this triangle on the ground that we're trying to solve. We've got to get more information about it. And we also have these triangles on the side, these 90-degree triangles. And so we're going to actually like use the 90-degree triangles to find more information about the triangle on the ground. So we can say that using the 200 and the y, we can say that tan 9 is 200 over y. Cross multiply the y and the tan 9. So we get y is 1262.75. Same thing on the other side. We get z is 866.29. And then using the cosine law, it's kind of like Pythagorean theorem, but minus the 2ab cosine 142. And it looks ugly, but that's because they're big numbers. So we just have to be careful, punch things in the calculator. My advice would be to get these two numbers first, and then to actually do this second, or do this third. This is actually becomes a negative, becomes a positive because of the cosine 142. The cosine 142 is actually negative. And so we'll see why more when we start studying angles above 90 degrees. But when you do it in your calculator, cosine 142 comes up as negative. So these four things multiplied together give you positive 1,725,000. Add those up and square root. Just like in Pythagorean theorem, you get 2017.51 meters. Very similar question. You've got 50-meter high bridge, and we've got two boats that you're looking down at. The difference here is the question's not, the 142 is actually now 110. So the angle is actually between the lines of sight. So it almost looks the exact same, except the 110 is up top. It's like up here as this big triangle here that we just redrew. One helpful thing about doing a 90-degree or 3D triangles is if you want to redraw them, it's a really good strategy. Okay, so now what we're looking for is we need to find more about this triangle because we need this length between the two boats. So we're going to solve for x using the right triangle. And same thing here, we're going to solve for this side using the right triangle. So we know that sine 38 is 50 over x. It's very similar to the tan question. 50 divided by sine 38 is 81. Find y, very similar. So it's just like a lot of work, but it's kind of this very similar work. This is SOHCAHTOA using the right triangles. If you want to redraw this as a right triangle flat on the page, that might be helpful if SOHCAHTOA is not something that's like really quick for you. But if you see sine 38 is opposite over hypotenuse, sine 35 is opposite over hypotenuse, you can do it that way. Now using x and y to solve for z, we can use the cosine law, very similar to the last question. Again, cosine 110 will be a negative, so the third number should be plus, because a negative times a positive times a positive times a negative is a positive. Add the three numbers, take the square root, you get 137.98. For rounding, notice how I try to use as many decimals as I can. If I round a little bit, it's going to be less accurate. So whatever I'm willing to use for decimals is going to help me in accuracy. And there's a bunch of practice.